though, is what day of the week do you suppose eggs hate the most? It's very important. Yes. Well, that's the month. What day of the week?
Friday.
Friday? Friday, yeah. Absolutely.
What day of the week?
So, that's okay.
February.
What was the reasoning behind February?
February.
What?
You need a reason for February? It's February.
Oh, I suppose, yeah.
Well, actually, it's technically February.
Nobody likes February.
February.
Thank goodness February's in our rearview mirror anyway.
Extra hard on days.
Can you believe that when you walk out of school today, it's going to be like 60 degrees?
Is it actually?
Yeah.
I'm not going to live in them.
Why is it that I like egg puns so much?
They're exciting.
I like it. Looking for something else, though.
Excellent.
They're excellent.
Also good.
February.
Also cool.
February.
They crack me up.
Why do
Yeah.
you think I like eggs on drugs so much?
Should I ask?
Crack.
Anyway, let's move on.
I'm not gonna pass.
No.
Keegan needs to cool off.
Yeah. It's nice. It's National Nice to Andrew Week, and I'm really just not about to take it.
It is
Oh, boy.
National Be Nice to Andrew Week.
I'm glad I'm recording this one. What is the best angle to fire a projectile at to get maximum distance? What do you think?
He's recording.
35? 45? Okay.
90.
90? No.
360.
It's not going straight up.
Yeah.
Straight up.
Straight up.
5 minutes and this class is already in the can. 45 degrees is the correct answer.
I'm proud you had any
Good
of
job.
Genuinely, that makes sense.
All right. We got some practice to do today.
That was excellent.
Absolutely.
I'm gonna lose it. I'm gonna crack.
What
Well,
are
He's
gonna crack.
No more talk about crack.
But what if we want to play Naked Twister?
What is that?
I'm so sorry. I am so sorry. My career is over.
It's just begun, Dr. Jensen. Right now you hear Mr. Hathaway to Dr. Jensen's office.
Okay.
It hurts so bad.
This is an arrow.
Oh my God.
And this arrow represents the velocity of a projectile.
Oh, I need a breather. Mr. Hathaway, you like my outfit?
That is very nice, actually. Okay. So 30-degree angle. This object is launched at 10 meters per second. And it's launched from the ground. It's not from any height above the ground. What I'd like you to do is I'd like you to use your equations. Tell me how far away from this spot it's actually going to land. So you're calculating x, horizontal distance, horizontal range, whatever you want to call it. Go ahead and figure that out, please. I'm not going to put the equations on the board this time because you need to make sure that you're able to take those off the equation sheet because you will be using that on a test. Those won't be on the board. If you need an equation sheet, let me know.
I need a Q-tip. Just my ears. Yeah. Thank you. You're welcome. I need to get those to you.
Okay.
But I couldn't figure them out. And I didn't have any time. But
I appreciate that. Was I singing that?
it was excellent. I did this one.
Too bad Sam's missing this show.
Sam would just be on his phone.
Yeah.
He's a jerk. He's such a nice guy.
He's such a nice, he really is.
He really is the nicest guy.
Oh, talking about our fake. No, Andrew, I told you. His Chinese letters is his name. Regular letters.
And then he was up until 4 in the morning. Really? Oh, because like it was me, Jack, and Owen in the back, and like I'm half asleep. And Jack's like, I don't know, a little less tired than me. He's just talking to us. Jack, like, I said, it's bedtime now. Kristen would not shut up.
Get as far as you can in the next 2 minutes. 2 minutes. This is a two-step problem. It's at ground level there.
What are we looking for again?
You're looking for distance, x.
Okay.
You want to go tanning with me after school? Today? Yeah, you want to go tanning?
I can't. Why?
What do you mean you got
You right now.
You know, the last time I saw your keys, they were on the couch where we were sitting.
About 30 seconds. Get as far as you can. I don't want to spend too much time on this one because most of the questions on the test will not be angled questions. They'll be something rolling horizontally off a table or something like that. So we'll spend more of our time on those. But finish on up. Depends on
Me.
how much you know.
I'm usually okay, but like I just sometimes brain fart and like forget everything.
Okay.
I
I think you'll do okay, Keegan.
I do appreciate how like the tests are not like at a different scale. It's all just points,
Yeah.
which is super helpful.
Yeah, that's too much thinking for me to do like those percentages and everything.
Oh my god!
I just make the test worth more points.
Last year, like I would always stress out my grades, and I had this more of a biology,
Mm-hmm.
and like at the end of the semesters, like I would no joke like me and her would calculate what I would need to get on something for me to not get an A or to get an A. Like we would just sit there like class periods doing that.
Sure.
It was funny.
I
It was
just
so helpful. Oh my gosh.
I just suck at it.
Thanks, Jeff.
So I just don't.
Well, that was a lot. Okay, guys, so let's take a look at this. Did anybody end up with a distance of 8.83 meters? Yes, very good. Okay, so let's go through this together. Make sure that we're all on the same page. Step one. Listen up, guys. Keep it down, please. Step one on this process is to take your velocity, and you have to break it up into its x and its y components. The reason for that, all these chords. The reason for that is because every single equation that you have in the motion box, all 6 of those on the top right that you'll mostly be using, those are all either vertical or horizontal equations. So we need either vertical or horizontal velocities that we can plug into them. This 10 is not going to go anywhere in any of those equations. because this is not vertical or horizontal. So to figure out how much of this velocity is horizontal and how much is vertical, we make a triangle.
Oh, yeah.
So this would be our velocity in the x direction, original velocity in the x direction. And up top here, this would be the original velocity in the y direction. So the x direction is the adjacent side of our triangle. So that means we got to use cosine to figure it out. So cosine is equal to adjacent over hypotenuse. That means,
X, right?
yep, cosine of 30 is equal to adjacent, which is velocity in the x direction, over the hypotenuse, which is 10. Therefore, that velocity is 10 times the cosine of 30. Now, in the y direction, we're using the same triangle, but this is the opposite side. And in order to do the opposite side, we have to use a sine function. And it's going to be this exact same equation. You're just swapping out the cosine with sine. So when we do that, we get our two velocities. In the x direction, we get 8.66. And in the y direction, we get an even 5.
Wow.
And these are the numbers that we're going to use as we try and figure out how far away from this spot that the object is going to land.
February.
Now, in order to solve for that horizontal distance, there is only one horizontal distance equation that we actually have. X equals vt. Do I have my velocity?
Yeah.
What number is it?
8.66.
Yes, it is not 10 because that's not a horizontal velocity. Very good. So we got to solve for time. There's two ways to do it. There's the quadratic way and the non-quadratic way. Let's do the non-quadratic way first. So when you're looking at your equations, trying to figure out one that you can solve time for, this one kind of jumps out. Well, I'll use different color.
Nice.
This one kind of jumps out at me. V equals VO plus AT. Because, remember, this is a vertical equation. If I'm going to use it with acceleration, what's the final, let's start with this. What's the original velocity going to be? 5. Because originally in the y direction, I've got a vertical velocity of 5. What do you suppose the final velocity is going to be?
Probably less than 5.
So, if this object,
So over time, it's going to slow down.
good guess, if this object originally has a vertical velocity of 5, when it comes
Oh, it's
back
coming
down to the
down.
ground, it's going to have a velocity of negative 5.
Wow.
It's like if you throw something up at 100 miles an hour, when it comes back down to your hand, it's going to be traveling at negative 100 miles an hour. That has to do with conservation of energy, which we're going to get into in the next chapter. But anyway, that's what you would have. Acceleration is negative 9.8, and then you could solve this for time. And if you solve this equation for time, you're going to get 1.02 seconds. So then you'd take 1.02 seconds, plug it in there, multiply it by the horizontal velocity, and you would end up with your distance of 8.83 meters.
I'm bleeding.
Now let's do the quadratic way. Okay. So for the quadratic, you're probably used to using that long y equation, and that's a good habit to get into because this is going to help you out in a lot of different cases. Final height is, of course, 0 because it's going to hit the ground. Original height is 0 because it comes from the ground. Original velocity, what's that going to be?
Oh, 5.
5, because this is a vertical equation. So that original velocity will be the original vertical velocity of 5. And then 1/2 times negative 9.8 is equal to negative 4.9 t squared. And now you've got your quadratic. Negative 4.9 is your A. Positive 5 is your B. 0 is your C. And if you plug all that in properly, you should end up with a time equal to 1.02 seconds. No surprise there. Now, one thing I do want to mention when you are plugging this in, and I'll just show this to the folks at home there. So this is the quadratic right there. And if you look at the bottom where it gives me the number, it gives me the number as 1.02, but next to it you can see the other number that usually is a negative is a 0 here. So the question is, why is that a 0 and not a negative value? Well, the reason is, usually, like right now we're being launched up at 30 degrees. If we were launching down, then that negative value would be the amount of time it takes to hit the ground if we were launching down. Well, here we're launching right from the ground. So if you launch it down, you're going to have a time of nothing. That's why you get nothing for that negative value that usually is a negative value out of your quadratic. So 1.02 seconds again could go in there. You end up with the exact same answer of 8.83. Questions on this? Okay. Nothing else? At least there's a lot of pretty colors on the board.
Christmas.
I do like it.
Now, most of the questions on the test are not angled projectile motion problems. Most of them have to do with objects that are maybe just dropped vertically, or maybe they're rolling off a horizontal table, and those are easier to deal with. So let's spend most of our time on that. Now, we got to get real for this. Who do we think is the fastest runner in this classroom right now? Probably Andrew? All right, Andrew, you're going to be our volunteer.
Just as fast.
Or Xavier?
Yeah.
Okay. So either Andrew or Xavier are going to be, well, for the sake of the question, we'll say it's Andrew.
Peek my head in.
No, you're not. You're not. Students aren't supposed to be on camera for legal reasons. Your voice is plenty.
Hi.
So I took a. You can actually sit down.
I thought I was running.
You are going to be running in this picture, which I took earlier today.
This is like a green screen, or?
All right. So here's the scenario, everybody. And this is what you're going to want to write down. I know the height of our school. It is 9 meters tall, which comes to about 30 feet. And I know the distance from the bottom here all the way out to the curb. That is 17 meters.
Really?
Yep.
Only 17.
Now that's in meters. So that would be like, 50-some feet. So that's quite a ways.
Yeah.
So, a good sprinter can at least get up to 20 miles an hour. So we're going to say that Andrew is on the roof, running at 20 miles an hour, and he runs off the top of the roof.
That sounds accurate.
Yes. I'm pretty sure. Please, go to real life.
When
Hey,
converted to meters per second, 20 miles an hour comes to 9 meters per second, conveniently. So here's the question that you need to figure out. Where does Andrew land? Like, does he make it to the curb, or does he land over here? Let's get some quick guesses before you guys calculate this. Where do you think Andrew is going to land in this picture?
On top of that pole.
On the pole here?
Yeah.
So that would be like, that might be 3 meters or so. Yes. In the tree, perhaps. maybe
Well,
here.
I like that.
There's the other guess. Anybody else?
Realistically, I'm probably running to the roof of the building in front of the school. So I'm running over the air onto
Oh,
the
I
top of
see.
the building. No, probably right around where the 17 mark is.
Okay, so maybe right around here. Maybe you'll land
Probably in the
nicely in the
in the tree, probably.
on the picnic bench there.
Oh yeah, that would be nice.
Okay, so go ahead, figure this out. Where is he going to land? Go.
Oh, I think I can figure this out.
All right. Well, it's about time.
Never mind. I'll erase some people now. Keegan, you want to erase me after school? Let me erase you.
Because I don't want to miss.
You scared you're gonna lose?
Yeah.
Why are you scared?
Because I don't want to crash my car.
No, race on foot.
Oh, sure.
Really?
Yeah, I'll be
No, you won't.
faster than you.
I have running shoes in my car. You won't catch me lacking with Jordan on.
So here's the thing, I just might.
No, you're not. You're not faster than
No, I'm gonna murder you.
in a race. You're not.
No, you will.
Good.
But
I'll beat
after next year.
I'll beat you in the race, and then you'll get upset and you'll murder me.
Kind of like how you got upset.
It was 2K. I could care less.
We couldn't care less at the time. Real mad.
Finish up the next minute.
You were.
Any excuse that you gotta make. Sure.
I didn't even get to play you with the Raptors.
Then you decided to throw a hissy fit and go to bed.
Yeah, that's why you're the one who apologized.
Yeah, because it's nice to answer you.
No, you apologized to me before it was being nice to you. You knew that you were being mean. You guys as a unit.
Like, hard to not.
It got hard to not be nice or to stop being mean.
Yeah, it's like,
That's just called general decency.
it's hard not to laugh. It's like everybody was just crapping on you.
Yeah, that's how it is every single day.
No, it's not. It's not like to that extent.
Keegan, you're not around me all the time at the games. They just make fun of me relentlessly. That's how it's supposed to work. But I'm just tempted. You guys had reversed the joke to make
All right.
it before I got downstairs.
What did you find? Did Andrew make it all the way to the curb?
Yeah. I got 22.95.
Okay. Anybody else?
Probably wrong, but.
Seeing other people shake their heads.
I got it right, I used it wrong for last week.
Oh, that's okay.
But I got 8.45.
Okay.
No.
So we'll go through this one, but that is correct. Andrew did not quite make it to the curb. And we'll find out exactly where he lands based on the equations that we're going to do. Now, we're looking for horizontal distance. That means we must use a horizontal distance equation. X equals vt. Now, I know my velocity is 9. I got to solve for time now. So if I'm going to solve for time, got to use this equation. Final height is 0. Original height is 9. Original velocity is going to be what? Is it going to be 9? 0!
Oh, that's where I messed up.
Because this is a vertical equation. That means this original velocity must be a vertical velocity. And of course, he's just going off the rough horizontally, so he doesn't have a vertical velocity. So that's 0. 1/2 at squared. 1/2 times negative 9.8 is negative 4.9 t squared. So, I didn't say yet. But yeah, so,
Yeah, you did.
did I?
Oh, wait, no, you didn't.
Okay. We'll find out in just a second here. So 9 goes over here. That's going to cancel out with that negative 4.9, because the 9 becomes negative when it goes over there. So, in order to solve for t then, divide both sides by 4.9. And in order to get rid of that square, we erase it. But if we erase the square, we got to square root the other side. And when you do that math, you'll get a time of 1.36 seconds. So if we take that 1.36 seconds, plug it in there, multiply it by 9, what do we get? Sorry, what was that?
12.195.
Yeah, 12.195. We'll say 12.2.
That's pretty good.
That is pretty good. You're not making it to the curb, but
No, but I'm close.
yeah,
I'm at like the end of where the benches would be, right?
you'd probably land for 12. Yeah, you'd probably land in the tree. So you'd be just fine.
Hey, my prediction is pretty close.
Yeah. Okay.
Really? Wow. At like the base of the tree, though, I'd probably hit my
Yeah.
head on the base.
Yeah, but you might be able to grab this branch. You
Yeah,
know?
I could grab a branch. I wouldn't be able to survive. We should try it.
Okay. We'll save it till the end of the year.
We should save it till the end of senior year. So I don't have much going on past high school.
Okay. So let's take a look at this now. We know Andrew can't make it to the end. 20 miles an hour isn't quite fast enough. So now what I'd like you to do is figure out how fast you need to be going to actually make it all the way to the curve. So now solve for velocity up here. You know your height, you know your distance. Find that velocity.
My guess is around 12.
We shall see.
My guess.
This one shouldn't take very long. No more than 60 seconds from now, have your answers. Anybody get an answer they feel confident in sharing? 12.5. How many people got 12.5? Good.
No, I was so close.
I got
You were.
13.5.
Dang,
So-
dude, I should just guess on all the problems.
Here's, please don't. So, in order to solve for this velocity, this is a horizontal velocity again. So we got to go to a horizontal equation. So if I take this equation, solve it for velocity, it's just distance over time. We know the distance. No, you're not. The distance is 17 meters. What about the time? Exactly. So even though you're moving at a different velocity when, whoever's running off the roof at this speed is actually doing so, even though you're going at a different speed, it's still going to take the same amount of time for you to hit the ground. Because vertically, gravity is going to act on you the same whether you're running fast or whether you're just walking off the edge. Because it's independent of your horizontal motion. So the same time that we calculated in the previous example is going to go right here. And that was 1.36.
So I would only have a minute and 36 seconds. I mean, a minute and 36 seconds in the air.
What?
Oh, sorry, I'm tripping. I meant 1 second.
Yes.
What?
Gravity speeds you up real fast when you leave that roof.
Literally did not mean minute. I was just being dumb. But like,
Also, if you want after 28 miles per hour.
Yeah, you're going to be going pretty fast on your way down, that's
what
for
if
sure.
I drove a car off with it?
Well, we're going to find something else out right here. One thing else to keep in mind is, even though the motion kind of looks, it looks like an arc if you were to draw this. Even though it looks like this, and Andrew would land at the tree,
It would more be like a diagonal, right?
no, this would be accurate because gravity makes you increase your velocity vertically every second. So your vertical velocity is increasing as long as you're in the air. But horizontally, your motion is going to be the exact same. Horizontally, you'd still be moving at 9 meters per second this entire time. But vertically, you're speeding up, which is why it looks like it curves down so quick like that. You're not actually slowing down horizontally, you're just speeding up vertically. So, just wanted to mention that.
Negative Y direction.
Yes. So here's the thing. Andrew is a little depressed because he didn't make it to the curb. But he's alive because he made it to the tree. So, we're going to go back to him, moving at 9 meters per second. But we're going to do something special now. We are going to take this part of Martin Luther High School and we are going to shift it to the moon in space. So, what I want you to do is tell me,
Wanted to be an astronaut.
I want you to tell me how far away from the bottom of the school he's going to land if we are now on the moon. If we're on the moon, gravity is no longer equal to negative 9.8. It's equal to negative 1.6. So, let's see how much time I should give you here. I'm going to give you 60 seconds. Get as far as you can. We'll go through this together, and then that'll be all for today.
We're looking to find the distance again?
Yep. So with the moon's gravity, how far away will he land from the beginning of the school there? You think he'll make it to the curb this time?
No.
We'll find out. You're solving for horizontal distance. How far away will he land from the beginning of the school there? And we'll go through this pretty quick in just a sec here, but
I might actually be able to give you a valid answer in
Nice.
class. Learning.
so some people get answers already? What'd you get, Sarah?
I got
30.1 something. That is absolutely correct. Anybody else?
I didn't have to.
Good. We'll go through this together. Just for the record, if we were on Earth, the speed that you would need to actually make it all the way to the curb, which we found to be 12.5, that comes to 28 miles an hour. The fastest person ever recorded going at a top speed was Usain Bolt, and that was 27.8 miles per hour. So he could make it to the curb, but pretty much him alone. So in terms of this, if we want to figure out horizontal distance, how much time we got? Minute and a half.
What was the answer?
We're going through it right now. So x equals vt. We're looking for that horizontal distance. Horizontal velocity is 9, so now we got to solve for time. And the way we would solve for time is the same way we'd solve for it in the other question, like this. So final height is 0. Original height is 9. Original velocity, once again, is 0 because he's running off the thing horizontally, not vertically. So let's see here. 9 equals 1/2 times 1.6 is 0.8. T squared.
I got that one.
Okay, negatives cancel each other out. 9 divided by 0.8 equals t squared. To get rid of the square, we erase it. Then we have to square root the other side. And what do we get for time on this? Yes?
3.35.
Yes. Very good. 3.35 seconds. Plug that in for time. Velocity is equal to 9. If done properly then on your calculator, you'll end up with a distance of, I got 30.15, 30.2, something like that.
Yo, I know how to do physics. That's hype.
So yes, at that speed on the moon, you would end up in the parking lot next to the new dormitories.
No, like what I said before, kind of.
See you later, folks.
Yeah.